Today on the Priority Queue, open source DDoS detection with FastNetMon. Now, if you don't know what DDoS is, it's a type of attack common across the internet, short for distributed denial of service. DDoS attacks are tricky to detect and hard to defend against, but the chances are good that you'll be a victim of a DDoS attack either directly or indirectly at some point in your IT career. And if you go on up to packetpushers.net and do a search for DDoS, you'll find plenty of articles and other podcasts that we've recorded about the topic if you're ramping up. But today we're going to focus not so much on just what DDoS is, but about the FastNetMon project that does DDoS detection. And joining me is Pavel Odintson to talk to us about FastNetMon. He is the project leader. Pavel, welcome to the Packet Pushers Priority Queue, and jump right in by telling us what FastNetMon is. What is this project?
Yeah, so hi guys. FastNetMon is DDoS detection software. So it focused on idea to detect DDoS attacks and automatically apply filtering rules to block it. And one of the main purpose of FastNetMon is to save your sleep. So you don't need to wake up in the middle of the night to fix all things, find what's happened with your network. It just works for you. So FastNetMon is focused on the level 3 and level 4 attack types. It's very important to mention that we focused only on this kind of attacks because there are a lot of different types of DDoS attacks, and you need to have special tools for each of them. So we focused on the most popular amplification attacks and different kind of floods.
Well, now, there's a lot of DDoS products out there. There's a number of mitigation appliances that you can buy. There are DDoS services that you can subscribe to. They're pretty pricey, but they exist. So considering that some of these products exist, what drove you to start FastNetMon?
So it's a really interesting story because previously I spent a lot of time to find something solve my problems with DDoS attacks. So FastNetMon initially was published at GitHub in 2013. So it's about 5 years passed since we started project. So it was on GitHub since first days. You could check how we develop it, how we add new features, how we check different approaches to DDoS detection. And so it was born as a result of market research. I tried to find affordable DDoS detection software for three different kind of companies. It was a hosting company focused on low margin markets, and it was very complicated to find really inexpensive software or hardware to detect DDoS attacks. So, and from first days, it was pretty naive approach to develop FastNetMon. It wasn't planned very well. So from first days, I tried to automate my day-to-time task. So when I see some kind of issues with my network, I started TCP dump, I checked packets, I checked a lot from using SNMP, I checked graphics, I checked router CPU usage, and I tried to automate all these things. So, unfortunately, I had course in my university about C++, and I spent first months of FastNetMon project to keep my knowledge about C++ with new technologies developed since this time when I finished at university. So, it was very interesting story why we decided to use C++, because if you could check GitHub history, you could find that we tried to implement it in Perl, Ruby, in Python, Go language, and then finally we switched to C++ because of requirements about performance. So one of the key requirements for us was ability to handle 2 million packets per second, because our hardware doesn't have any support for NetFlow or SFlow, and we use a port mirror to capture traffic. And it was huge amount of information, and it was very challenging to handle all this amount of information and process it in affordable time.
That's interesting. I didn't know that C++ would have necessarily been a requirement. When you said Go, and when I think of Golang, I think of it as a language that's a little bit closer to C++. It's not as way up there as Python, where it's hiding so many things from you. I kind of thought, I guess I would have assumed, me not being a professional developer, I would have assumed that Golang would have given you the performance you needed, but not really, huh?
So yeah, really. So I think for if you have done some not so much traffic, you could use Go. But if you have something like 40 or 100 gigabits, it's definitely not a task for Go language, because it was developed with slightly different goals. It was about different logic, APIs, database application. But for packet processing, you need to handle information very fast. And also, choice of C++ was a result of available libraries for packet capture. So almost all of them provide binding for C or C++. And in these times when FastNetMon was started, Go wasn't so popular and was pretty a small amount of available libraries for packet processing. Unfortunately, in the last few years, a big number of new nice libraries was developed for Go language. And probably if somebody decided to implement something by yourself, and so Go works fine. Yeah, but I couldn't say same for other languages because they wasn't so cool in our tests.
Got it. Well, okay, so we've got performance is a major feature of FastNetMon, and cost, obviously, if your DDoS solutions, as you said, a lot of them commercially available are quite pricey. So now we've got an open source and highly performant solution. What are the other main features of FastNetMon?
So definitely main feature of FastNetMon is DDoS detection. So we provide number of options to detect time when DDoS attack hit your network and provide a lot of information about this attack. So from your side, when you're a network engineer and you need to know basic information about your network, so you definitely know that average traffic for this host in this subnet is something like about 100 megabits. And for different hosts, something like big cache servers, it's about 1 gigabit. So you could use this baseline and provide this information to FastNetMon. And when traffic to this host crosses this threshold specified by you, and so FastNetMon will check this traffic, apply number of heuristic approaches, check it, and provide or confirm. So it's definitely DDoS, or okay, it was false positives, don't bother your engineers about it. And when FastNetMon detected DDoS attack, it could trigger different actions. So it could call custom bash script, it could notify you using Slack, so you could it could write email to your network engineer or on-duty engineer to check it by yourself or check it manually, so what's happening with our network. And definitely, so we're passionate about automation. And FastNetMon have complete support of BGP, and we support BGP unicast and we support BGP flow spec. BGP unicast is more about options to block all traffic for affected /32 using black hole. And also you could trigger and create announce using BGP unicast for something like /24 and use diversion to scribing centers outside of your network. And also you could use BGP flow spec. It's very modern thing. And if you have a lot of capacity in your network and you have modern routers, so you could filter out a lot of malicious traffic using your own network without paying to expensive scribing center and expensive DDoS filtering hardware. So, and also in addition to DDoS mitigation detection, FastNetMon provides a lot of options and a lot of information about your traffic. So it provides information about average traffic for all hosts in your network. So it provides information about amount of UDP, TCP, ICMP traffic. It provides information bytes per second, packets per second. And also it provides options to export this information to different storage backends. So we support Graphene, we support InfluxDB, we support Graphite. And so if you already have some kind of solution used by market, so instead of installing new one, you could use existing deployment of system and just export this information from FastNetMon. So FastNetMon tries hard to avoid any complicated and significant changes in your network. If you already have something, FastNetMon will work with it. So it was also one of the key features when we developed FastNetMon.
Okay, there's a lot there. You were talking fast and saying a lot. So we've got detection. We've got a lot of different methods in which detection is done.
Yes.
In addition to that, there is a notification engine that'll hook into a lot of things. You mentioned you could call a script. You could send a Slack message to talk about the type of attack that was detected. And you mentioned BGP announcements that could be made where an attacker is announced as a route via unicast BGP family or via FlowSpec. And if you don't know what BGP FlowSpec is, if you're listening to this show, you can do a little search on packetpushers.net. And I recorded a show, in 2015 or 16, I think, with Justin Ryburn. He was at Juniper Networks at the time, and got into FlowSpec quite a bit and how it fits into the world of DDoS mitigation. So, okay, Pavel, that was a lot of things. This isn't like something that you grew in your garage last month and it's got three things it does. It does all kinds of things and feels like a more mature solution you can plug into your infrastructure. But I do have a question about detection versus mitigation. So it's one thing to detect that you're under attack. It's another thing to deal with mitigation. I mean, it sounds like there is some mitigation there where you can feed FlowSpec entries, for example. Talk through the distinction there. How does detection help me with the mitigation? How does FastNetMon do mitigation, or does it? Do you think of it mostly as detection? Explain those things for us.
So yes, it's very important to highlight difference between mitigation and detection. So we focused on the idea that FastNetMon is DDoS detection software. So we could detect when DDoS attack hit your network. We could provide information about the type of a DDoS attack, performance of this attack, and unfortunately, we couldn't provide mitigation in almost all cases, but because complete mitigation is more complicated. For example, when your attack hit by very complicated and sophisticated DDoS attack using L7 protocols with encrypted packets inside, so you need a lot of different hardware boxes. You need complicated software deployment to check and unpack all protocols and find anomalies inside it. So, and from FastNetMon point of view, it's FastNetMon represents only a small part of DDoS mitigation stack. And this stack could involve different parts. So as I mentioned before, we have complete support for cloud scrubbing centers. When FastNetMon discovers that you hit by DDoS attack, it could use BGP Anycast announce to and divert affected /24 subnet to cloud scrubbing center. Also, as options, you already have some filtering hardware in your network from different vendors. You also could use this hardware with FastNetMon, because FastNetMon have integration with a number of different DDoS filtering appliances, and it could provide information about type of attack and create specific host and filtering groups to configure filtering from these filtering appliances. So, and mitigation also depends on your goal. So if you have goal to save your network and you don't care about service availability and it's acceptable for you to block all traffic to affected host. So for example, it could be small VPS services or small dedicated service or some not so important service. And in this case, FastNetMon could work as mitigation software, because it could you could use BGP black hole to completely block all traffic to affected hosts in your network. And
as opposed to doing a scrub where you're trying to let legitimate traffic through while dropping bad traffic.
Yes, indeed. So, and in this case, unfortunately, you block all traffic to this affected host. But as good side, you could save all your network. Let's imagine you have millions of hosts in your network and you have 100 gigabits of malicious traffic to 1/32 hosts. So, from my point of view, in some option, in some cases, it's absolutely acceptable to save your whole network. And in this case, FastNetMon could be handled like DDoS mitigation software. So also it depends on your network configuration. So for example, if you have BGP FlowSpec in your network, we definitely could use FastNetMon as DDoS mitigation software, because FastNetMon could detect when a DDoS attack comes to your network. FastNetMon could find malicious patterns of traffic in this DDoS attack. So, for example, you think very strange fragmented packets of UDP protocol from strange ports. So it looks like UDP amplification, and we could create BGP FlowSpec rule to block this traffic completely using your routers. So, and in this case, FastNetMon detects attack. It provides information for your routers using BGP flow spec, and it filters it out completely. And so if this attack never changes to something more sophisticated, so this attack was mitigated, and FastNetMon worked as mitigation software.
Hmm. But I see the line you're drawing, though. I mean, detection is the primary function, and then once you've done detection, you're typically telling other devices to perform the mitigation. Here's what I found out, here's what I detected, and here's the sort of flow spec rules or whatever other information those mitigation appliances might need, or in the case of flow spec, a router might need to filter off the malicious traffic, and that's where the actual mitigation is happening in many cases.
Yes, and also we already have some sophisticated system which could handle this information and even provide additional processing for traffic samples collected by FastNetMon. You also could use it together with FastNetMon. So in best case, when you could combine few different systems or cloud services to provide complete DDoS mitigation for your network.
Okay. Now, doing my homework for this show, I noticed that there is the free version of FastNetMon, which is largely what we're talking about here, but there's also a commercial version. Can you explain the difference between the two?
So yes, indeed. FastNetMon was started as open source solution, but after some time we received a bunch of requests from different, it's more about from businesses, guys, because FastNetMon is open source solution, FastNetMon community. It was built with idea to work everywhere. It supports almost all Linux distribution. It works on FreeBSD. It works almost on almost all available architectures available in the market. So it works on ARM, it works on PowerPC. So, and it's this side, from this point of view, FastNetMon is very, very, very versatile software. And for commercial customers, it's not so cool because you need to find all these pieces by yourself. So it's more about Lego. So if you like to find database for your traffic, if you want some kind of special service to store your information about traffic. So, and you could combine it using FastNetMon in the complete solution. But so instead, it doesn't work well for business because for business side, you need to provide products. So, and that's why we moved to FastNetMon Advanced. FastNetMon Advanced consists all features available in FastNetMon community, but it provides it in single box. So instead of supporting different BGP diamonds, we added our own implementation for BGP unicast and BGP flow spec. We implemented command line configuration interface. We added APIs for complicated integration with different external systems. And we provide very, very, very nice install tools. So instead of compiling code from source, changing things, configuring different software, you just need to start install script and install everything what you need on your hardware. So that's one of the main differences. So it's about operational experience of FastNetMon.
Yeah, I'm hearing integration. You're just making it more of a turnkey solution. It's easier to get the platform up off the ground. So is that really it, or are there functionality differences as well between FastNetMon and FastNetMon Advanced?
Yes, so in addition to basic DDoS detection, we provide enhanced DDoS detection engine, which works very, very nice with BGP flow spec. So from difference in available options, it's one of the key features from FastNetMon Advanced. Because it instead of so from FastNetMon community, we support small subset of very popular DDoS attacks. But for FastNetMon Advanced, we support all available types of DDoS attacks and even multi-vector attacks, which could change in time. For example, it could start as UDP, then move to TCP, and finish as something very complicated, Guerrilla amplification. And FastNetMon Advanced could handle it. So because we reworked a detection engine a lot.
I want to talk about FlowSpec for a minute. So it's come up a lot. It seems to be growing in popularity amongst service providers as a way to perform DDoS mitigation, a way to get those access control entries from a detection engine into the routing infrastructure. So how has support been from the vendors? I mean, a year or two or three ago, when I talked to Justin about this, it was just emerging. A lot of the OSs didn't even support it yet. Is FlowSpec pretty much available everywhere now on all routing platforms, and does it work pretty well on the whole?
So, first part of response, unfortunately, it's available only on modern and very expensive hardware routers. So you couldn't find it in inexpensive boxes, so because it requires a lot of work from hardware side of routers. So it's very unlikely to find BGP flow spec support in software routers. And usually it's top models from vendors, and fortunately almost all top vendors have options to use BGP flow spec on their routers. So we have very nice experience with Cisco routers, Juniper, Huawei, and almost all of them work pretty fine. And so you definitely know that BGP flow spec, it's not so simple protocol from implementation side, and different vendors have some small differences in implementation. But fortunately, I think about last 1 year, almost all of them was fixed on reworked, and right now FastNetMon from our side of bundled BGP daemon of FastNetMon, it works really well with all different implementations from vendors. And it's really good because it's very complicated to find something which works out of the box. And BGP flow spec, it's a great example of technology which really works and works according to standards and according to RFCs. And it was really amazing to see it in the wild, because when we started our work on BGP Diamond, so it started to work since first our tests runs. So we started to establish BGP session with router, and it handled our BGP flow spec announced from first attempt. It was really amazing because we started as abstract implementation about from standard, nothing about the applicable test, nothing about real world test. But it works. It was amazing. Really.
It is amazing.
It's really amazing.
To get it right the first time just based on the standard, and almost nothing ever works that way. There's always some little detail, some little problem, somebody interpreted things a little differently, and so it never works right out of the gate. So that's pretty fascinating.
Yes, to be honest, in next few months we discovered few small issues with slightly different representation of protocols and fragmentation flags, and when we fix it, it works fine for all of them. So so if you are looking to develop your own solution for DDoS detection, it's very good point to have support for BGP flow spec.
So who do you think the typical user of FastNetMon is? Is it more service providers, or is it enterprises? Is it a mix?
I think it's some kind of mix, but unfortunately it's very complicated to provide reliable information about who our customers are, because for last 3 years, we have about 5,000 downloads, and for community version we don't have any information about who these guys are. So, and according to our experience from mail list and our chats and IRC, I think one of the major customers, telecoms and hosting providers, a lot of data centers, and in last quarter we discovered a number of wireless service providers interested in our solution.
Okay, and that does make sense. That aligns pretty well with the kinds of folks who are typically going to need to be able to detect and mitigate DDoS attacks. So that makes a lot of sense to me. Okay, hardware requirements. So FastNetMon needs what? Tons of. You wrote it in C, so it's very efficient. But do I need a big box to run it on?
You definitely don't need big expensive box, because FastNetMon really have very small requirements about your hardware. So it could work just on single CPU machine. It's better to have 2 CPU cores because we have 2 different cycles. One of these processes handles incoming packets, and the second one provides information and runs notification. But it could work with single CPU machine. So single CPU machine.
Okay. Well, you mentioned 2 CPU cores. Would it benefit me if I had a quad core or more machine?
Yes.
Or just the 2 is really what's important?
Yeah, at least 2. So if you have something like 48, it's fine. FastNetMon could work on all of them and provide a lot of performance for you.
Okay, so yeah, I got to run it on. It's not a killer box, you're saying, and then what else? What else do I need in this box? How much memory? What sort of OS, etc.
So I think from memory side, you could start from 1 GB of memory. So And it depends on size of your network. If you have something like 100,000 of hosts in your network, that's fine to use 1 or 2 gigabytes of RAM. So if you have millions of hosts in your network, so you need something like 4 or 8 gigabytes of RAM. So, but I think it's still affordable requirements about memory because it's a kind of standard.
You mentioned a bunch of different CPUs. I was assuming just x86, but you actually support ARM and other things that you mentioned.
Yeah, it's really amazing because recently we added FastNetMon community in Debian distribution, and it's become part of it. And if you want to test FastNetMon, you don't need to run any custom install scripts, check our guide. So you just start package install for your favorite distribution like Debian or Ubuntu and install FastNetMon in single step. It's really amazing. And then, as when we added to Debian, so we spent some time to port FastNetMon to different architectures. So we had the support for ARM, we had the support for PowerPC, and almost all architecture available in Debian supported by FastNetMon. It doesn't make a sense if you want to run it as standalone instance on your own server, but it makes sense if you want to start FastNetMon somewhere in your router or directly on your switch. It's really a nice option to reduce the
I hadn't thought about that. Yeah, okay, run it like NFV style, run a
Yes.
virtualized instance of it and embed it into your network with a router platform that can handle running an extra process.
Yes, and fortunately, you could find a number of different switches and routers where you could run your own software on them. So instead of having different box placed in your rack, so you could use same box for everything. So you could route traffic, you could switch traffic, and you could detect DDoS attacks in same box.
Okay, so I've got a pretty good idea of the platforms that I can run FastNetMon on. Now, my network itself, is there any unusual requirements or anything I need to be thinking about to get FastNetMon going?
Fortunately, we don't have any special requirements for your network. Really, because I know how it's complicated to change something in big networks. Sometimes it's almost impossible. And from first steps of FastNetMon development, we started FastNetMon as completely vendor-neutral toolkit. We don't have any we have small optimization from different vendors, but we never restrict your buy. So we work only on this vendor's name. No, never. If your vendors have support for SFlow, NetFlow, and BGP, it will work with FastNetMon without any problems.
That leads me right into my next question then. If I want to export traffic to my FastNetMon monitoring, what's the best way to do that? Flow records, or should I be using like a span port or a mirror port or a network tap? What's the best way?
So it's very complicated to find best way. We have few recommended options, but usually you're restricted by your hardware. So I never saw any hardware which could support something like NetFlow and SFlow in same time. So usually if you have big number of routers in your network, usually you have support for some kind of NetFlow like protocol implementation. It could be implementation about JFlow, CFlow, NetStream, or something like this one, but it's internally it's flow-based protocol. And if we are speaking about switches, usually you could find support for SFlow. It's also a nice thing because it's sampled protocol, and it provides very nice detection time for FastNetMon, because instead of NetFlow, it doesn't have any delay for flow aggregation. And also, in worst case, if you don't have NetFlow and you don't have SFlow in your network, we could use last resort. You could use port mirror, and FastNetMon tries hard to handle all your traffic. So as I mentioned before, ports mirror capture was one of the first features of FastNetMon, and that's why we support all wide range of supported bandwidth. So we support 1G, we support 10G, and recently we had support for 40G interfaces, and we use very, very optimized zero copy float engines to handle and parse all this traffic using FastNetMon. And so if we add a few words about hardware requirements, unfortunately, in case if you want to use port mirror, you need more CPU resources. And on good sides, FastNetMon scales very well. If you need more traffic, you just need to add CPU cores and small amount of memory, and FastNetMon could handle all this traffic amount.
A couple of follow-up questions. One is, did you say IPFix or IPFix record supported?
Yes, we support IPFix.
Okay. And then what about sampled versus unsampled flow data?
It's also about your hardware, because for number of different models of routers, it's impossible to use unsampled NetFlow. So you should use sampling if you don't like continuously overload that control plane of your routers. So FastNetMon supports sampling, but unfortunately, it implemented a vendor-specific way. And for different vendors, they use slightly different options to encode information about samplers for NetFlow 9 and IPFix. And in worst case, you need to specify sampling rates for all your devices or global for your network manually in FastNetMon configuration.
All right, so FastNetMon against other commercial products. Now, as we said at the top of the show, there are a bunch of commercial products out there. They tend to be pretty spendy. So if I'm on a budget, I might look to something like FastNetMon to give me DDoS detection without having to spend big on a commercial product. Do you see FastNetMon as being able to replace certain commercial products that are out there, kind of going right up against them, or not so much?
I think I have small change for your question, because FastNetMon never against it. So FastNetMon could work together with different solutions. So
okay, complementary, not competitive, possibly.
Yes, definitely.
Okay.
Because if you have big number of different hardware for filtering, they implement different approaches, and they implement slightly, and they could provide more options to filter out traffic better. So if you could mix them, you could provide better results. And we right now, from FastNetMon side, we have integration with A10 networks TPS appliances. About 1 year ago, we added support for Redware, Defense Flow, and also we support number of different models from MikroTik. So if you have some time for writing code and you want to improve your skills in Python or Go language, you could contribute your own implementation and integration with your vendor and contribute to the FastNetMon community, and we will add this support. And finally, you could use all your different vendors together to solve problems with DDoS attack detection and mitigate it very, very efficient.
Well, I think that's a major point that's worth making here, is that FastNetMon, if you're using it as open source, one of the reasons you might want to do it isn't to save money, save capital expenditure, but to be able to customize a solution that works very well or exactly for your specific business need. So you're looking at it because you've got some specific problem you want to solve, and you need an open platform that allows you to write that code to do exactly what it is that you need, that maybe a commercial version wouldn't give you that flexibility.
Probably could provide this kind of flexibility, but yes, if you want to build something by yourself and you have staff of C++ developers, you could change almost everything in FastNetMon community, and you even could contribute back to project and improve it. So if you represent hardware vendor, or you building your own appliances, you could contribute support with compatibility with your API and improve support for your, for example, NetFlow implementation. For example, contribute nice parser for your IPFix approach to encoding sampling rates and IPFix. It's absolutely fine, because you could improve our product for everybody. So you improved for you improved for other customers of FastNetMon. So
okay. All right. One of my standard questions about these sorts of things: IPv4 versus IPv6. How are we doing? Do we have feature parity in FastNetMon or not?
It's a very good question. It's shame on us. Unfortunately, we have a number of design decisions in FastNetMon, and they make implementation for IPv6 pretty complicated. But we're working on it, but I don't think that we could deliver it in less than 6 months, because it involves significant reworking on FastNetMon detection engine. So we're working on it, yes, and fortunately we don't worry about a significant amount of IPv6 baked DDoS attacks. Unfortunately, IPv4 is still main target of DDoS attacks, and so we have some time to finish it.
Yeah. That makes sense. Why would you, if you're an attacker, what transport would you want to use? Well, you'd want to use V4. You've just got more targets of opportunity out there. IPv6 actually restricts you somewhat, especially down more into the mobile space, which doesn't even make a lot of sense depending on what it is you're trying to set up a DDoS attack against. So I get it where IPv4 ought to have been the focus, but also it's good to hear that you are going down the IPv6 road. And it's going to take you a while. I hear that, but yeah, you're going there. Okay, so what? FastNetMon's collecting all of this flow data and coming up with interesting things about my network from a DDoS perspective. Will it also tell me things that might be interesting other than DDoS detection?
Yes, sure. In FastNetMon Advanced, we add the traffic persistence engine, and this engine could store all flow on all packets received by FastNetMon in persistent storage. So, and this solution provides very good scalability, and you could retrieve information, for example, how much UDP traffic I had 2 years ago, and it will handle your response immediately. So, okay, not immediately, in 3 seconds. And you could use this information to provide peering reports, for example, how much traffic we have with this autonomous system, how much traffic of ICMP we have for this subnet. And FastNetMon provides all this information from very, very fast storage backend.
And again, you said FastNetMon Advanced, so that's the commercial bit, right?
Yes, it have options to work as NetFlow or IPFix aggregator. Yeah.
Now, what about in the community flavor?
Unfortunately, we don't have any support for this feature, so we moved this feature to advanced version only.
Got it. Okay. Now let's say we talked a little bit about these integrations, like with A10. I've got a DDoS mitigation tool in my network. So how is that integration working? Does it get a data feed from FastNetMon? How does that work?
So yes, if you already have some solution in, for example, A10 box, so usually they have support for NetFlow or SFlow streams, and you could consume this information on FastNetMon's site. And so also you could mix these streams for example, from i10 box and from your routers, and mix this information together, because FastNetMon have unlimited number of different support of NetFlow agents. So you could collect information about number of routers and mix this information in single place and combine it. So.
All right. Kind of a related question. What about an API? Does FastNetMon have an API or some other interface that I could use for automation or to pull information out of the system?
Yes, sure. It also depends on edition of FastNetMon. In FastNetMon community, we have very basic API implementation, and it provides only option to unblock risk block it by FastNetMon hosts in your network. In FastNetMon Advanced, we added complete support for in configuration and management and different actions for FastNetMon Advanced in runtime. So, and we also provide command line interface tool, and if you could change something using this command line tool, you could also change it using API. So, if you want to, for example, create new customer or host group from your billing system, or you want to export this information to your own DDoS mitigation system or your monitoring system, you could use this API to retrieve information from FastNetMon. You could retrieve traffic SAMs, you could retrieve information about attacks, or you even could adjust baselines for different hosts according to your external system. So it's also possible.
Okay, a lot there. Of course, now I'm starting to see where the difference is between community and advanced. Like, you want API? Yes, come to the commercial side.
Or write it by yourself and contribute it to us.
There you go. Well, speaking of which, are you looking for developers to help with the project?
So yeah, and FastNetMon is not so common open source project, because usually open source projects looking for developers. but we're looking more about guys and from hardware vendors, and we're looking for guys with experience with different protocols like NetFlow, IPFix, SFlow, because it's very complicated to write code, and it's even more complicated to write code for hardware you never saw in reality. So and from this point of view, it's one of the biggest options you could provide. How you could provide help to FastNetMon is to contribute your pickups for your specific and very strange hardware, and share your experience, share your ideas. So, guys, I don't like this option, how you implemented it. Let's rework it this way. And it's very
in other words, getting feedback from people about how they're using it and what they think of it is helpful to you as well, because being a developer in this particular project seems you got to do some coordination up front to make sure that you're going about it in the right way. It sounds like, yeah.
Yes, indeed, because it was a very, very nice market benefit for FastNetMon, because from first days we listen our customers, because if you are working for specific inside some specific market and you work with specific vendor, so it's very complicated to have complete understanding of whole market. And it's very important to have feedback from your customers, because you could understand that different networks have different goals. They have different options to solve problems. They have different problems. And it's very important. It's extremely important information.
Particularly if you've got some kind of an outlier bit of hardware that you're working with that you'd like to have integrated with your FastNetMon install. That would help you guys a lot, because you've only got so much stuff in your lab that you can test with.
Yes, it's almost impossible to keep all this stuff in our labs, because usually this hardware is very specific or very expensive, and it will be really nice to see more feedback from hardware developers, because they know a lot about their hardware, how it implemented, how it works in these circumstances, and it will be really nice to have feedback from hardware vendors about it. Because
So what is the community then for folks that want to interact with you? Is there IRC or Slack, or what's built around the project that people can join in?
We support almost everything. We support IRC, we support Slack, we support Telegram, we have Google group. So because different kind of people like different kinds of chats. So, and we have a number of people who participate in all of them, but we have subset of people who never tried something other than IRC. I like IRC. So we provide options to cooperate with us in IRC. And when we see significant requirements from our customers, so for example, oh guys, could I email you using this system? Yes, you could. I just created it for you.
Very good. It's been the same thing for us at Packet Pushers. We have an IRC channel that there's been 100 or 250 people in for quite some time, because there's some people that just love IRC. So we've got a Packet Pushers IRC channel out there on a free node. And we've got a Slack channel too, because a lot of people like that. And we've got an email box, because some people like to send us messages that way, and so on. Yeah, you got to support all the things. Well, Pavel, this has been a great conversation about FastNetMon. I have enjoyed this very much. Now, where would people go if they want to find out more about the project, or maybe they want to ping you? Can you share some URLs with them?
So definitely, it's better place to ask us for something. So you could start from our official site, it's fastnetmon.com, and we have references to our Slack group, we have references to our mail group, and we have a web client for our IRC channel. So you could find what do you like more and ask us using these channels. So we're open for cooperation and open for feedback, and in all time we maintain our product on GitHub, and you could raise PR or issue, and so report some issues or ideas and share it with us. So we have a lot of options to.
Very good. Now, you personally, are you social, like you're active on Twitter, or you have a blog somewhere that you'd like to share with folks?
So we have a blog on official site, so you could also read it. It's not so active, unfortunately, because we have a lot of nice things to share, but we don't have so much time to write posts. But we have a few nice posts about differences in implementation of NetFlow and SFlow protocols from hardware different vendor side. It's very interesting reading, I think, because it highlights our experience, how we implemented these protocols, what kind of issue we hit. So what kind of issue you could expect if you have a lot of devices with NetFlow, for example, from specific vendor, and you could check this guide. So I could recommend it.
I also know what you mean about the having lots of things to write but no time to write them. I have got lists and lists of things that I thought would be a great idea to write about. Every once in a while, I look at the list and go, oh, I should write about that, and then I do. But man, I got more ideas than I do have time to actually write them. So
yes,
thanks
sad.
for coming on the show today, Pavel. I really appreciate it. And to all of you listening, thanks for listening to the Packet Pushers Priority Queue today. You can find this and many more of our fine and lovely free technical podcasts, along with our community blog at packetpushers.net. We're on Twitter at Packet Pushers, and we're on LinkedIn. You can follow us there. We're on Facebook. And take a minute, rate us on Apple Podcasts. I know it's like a thing. You got to click stuff and then write words and click stars and things. But we'd appreciate it if you would rate us there, because that boosts us up on the Apple Podcast rating tree if you like what you're hearing. Last but not least, remember that too much networking would never be enough.